Assalamualaikum warahmatullahi wabarakatuh. We are students from Group CS 2485B1. The topic that we choose for Vector Calculus Group Assignment is Green's Theorem. Okay, so this is our group members, which are Natasha Nur Faiza, Luqman Hakim, Fatin Nurliana and me, Nurin Hanani. So I will be explaining about the introduction of Green's Theorem. What is Green's Theorem? The concept of Green's Theorem is referred to the relationship between integration of line integrals and double integrals. From the diagram, it can be seen that C is the closed curve and D is the region enclosed by it. D does not contain any holes as curve C is naturally closed. It also observed that the direction of curve C is in counterclockwise direction or known as positive orientation. To understand more deeply about this theorem, let D be the area where the positively oriented or counterclockwise direction of closed curve C in a plane is bounded. The Green's theorem can be expressed in an equation as if M and N are the vector field fxy, which is equal to Mi plus Nj defined on the region that contains D and have continuous first partial derivative. The equation of Green's theorem is as below, which is integration of m dx plus n dy equals to integration of f dot dr, or we can write it as double integral of dn over dx minus dm over dy dA. There are two steps in calculating Green's theorem. The first step is to find dn over dx minus dm over dy, then find the dA. The dA is classified into three types. The first type is rectangular coordinate dy dx, then another rectangular coordinate dx dy, and lastly polar coordinate r dr d theta. The Green's theorem can be proved as shown in the slide. From the general equation of Green's theorem, we derive two equations which are integration of m dx equal to double integral of negative dm over dy dA as equation 1, and integration of n dy equals to double integral of dn over dx dA as equation 2. So from equation 1, we let the interval of integration as a and b for the first integration and g1x and g2x for the second integration of dm over dy dx. Then we substitute the interval g1x and g2x into dm over dy, and we obtain integration of mx g2x minus m x g1x dx with the interval of a and b. The same step is used to prove the second equation, which is integration of n dy.
Assalamualaikum madam, my name is Natasha Nur Faiza binti Jumansa. I will proceed to question 1. Evaluate integral of xy dx plus x square y cube dy, where C is the triangle with vertices 0, 0, 1, 0, 1, 2 with positive orientation. So we proceed to solution. Step 1 is sketch the figure. From the equation, we got the information for points and direction. And the figure will look like this. Step 2, from the equation, we got the information n equal to x square y cube, m equal to xy. We can differentiate n respect to x. We got 2x y cube, and differentiate m respect to y. We got x, and we got 2x y cube minus x. Step 3, find the dA. We find the dA, we choose dy dx from the figure. Range for y is 0 until 2x, and range for x is 0 until 1. Step 4, integrate using formula. So this is the formula in green theorem. So we just substitute the value from the previous step and we got the answer 2/3.
Assalamualaikum warahmatullahi wabarakatuh, madam. My name is Luqman Hakim Muhammad Kamal. Now I will explain how to solve the first question using Maple. The first step is we need to load the necessary packages by using with vector calculus and with plot. The second step is we need to plot the graph, which is triangle equal polygon plot 0, 0, 1, 0 and 1, 2. The third step is we need to define the vector field components. We set P equal Sy and Q equal X square times Y cube. Next, we calculate the partial derivatives by differentiate P and Q. We will get dq over ds equal to 2sy and dp over dy equal to s. After that, we set up the integrand for the double integral and we get 2sy cubed minus s. Lastly, we set up the bounds for the region and evaluate the integral and we get the answer is 2/3.
My name is Fatin Oliana and I will explain the solution for question 2. So the question is calculate the line integral for this equation where C is rectangular with vertices 1, 1, 4, 1, 4, 5 and 1, 5 oriented counterclockwise. First, sketch the figure and the figure for this question is like this. From this equation, we know n is 2 minus 3y and m x cubed y. Next step, find dn over dx minus dm over dy where dn over dx is equal to 0 and dm over dy is equal to x cubed. So, we can get negative x cubed as the answer to this subtraction. Step 3, find dA. dA for this question is dx dy. Interval for x is 1 to 4 and interval for y is 1 to 5. Last step, integrate using this formula and substitute the information. Then we will get negative 225 as the answer.
Assalamualaikum, madam. Again, my name is Luqman Hakim. Now I will explain how to solve the second question using Maple. As before, the first step is we need to load the necessary packages by using with vector calculus and with plot. The second step is we need to plot the graph, which is rectangle equal to polygon plot 1, 1, 4, 1, 4, 5 and 1, 5. The third step is we need to define the vector field components. We set P equal to x cubed y and Q equal to 2 minus 3y. Next, we calculate the partial derivatives by differentiate P and Q. We will get dq over ds equal to 0 and dp over dy equal to x cubed. After that, we set up the integrand for the double integral and we get negative x cubed. Lastly, we set up the bounds for the region and evaluate the integral and we get the answer is negative 255.